Hi geographers, so welcome to part 2 of our lessons on coast. So last day we looked at the types of waves, deposition and erosional features, how they create depositional and erosional features. We went through what is longshore drift and wave refraction. So today we are going to look at destructive waves, constructive waves, and differentiating between the waves and go a little more in detail in the wave erosional processes. So let's go. So we said that constructive waves and constructive waves are here. Sorry, the board is slightly erased. Someone erased it this morning, but we'll just fill it in. So this is constructive waves. Constructive waves are formed between 6 to 10 waves per minute. They have what we call spilling breakers. So what are spilling breakers? So for example, if you look at the Caranage, Chaguaramas area, Williams Bay, that coast, the west coast is very calm and the waves, they literally spill. So it throws over very quietly. Compare that with the waves on the north coast, on the northeast coast like Toco, Maracas, Las Cuevas, well not Las Cuevas, Maracas, they have a very high wave crest and the waves are more destructive. So their breakers are what we call plunging. So constructive waves have spilling breakers, which is really a spill like when a glass of water spills, right? It's really gentle. They have a greater swash, so we spoke about swash and backwash last day. So the swash brings material up the beach, it forms a nice long beach. Then you have a low wave height, meaning that because they have these spilling breakers, the wave crest is not very high, they are very short or they are very low. So we have low wave height and they have a long wavelength. So what is a wavelength? If you're standing on the beach, let's say you are at the beach and you are looking out at the ocean, you will see where the crest of the wave is formed, which is the part that curves forward. That curve of the wave, right, the distance between that wave crest and the one that forms behind it, we call that the wavelength. So with constructive wave, you have what we call a long wavelength. So the time it takes for another wave to form is longer and they are low frequency, meaning that the time that it takes before you have another one forming is a long time. So the frequency of the wave, meaning how often it approaches the shore, is a much longer time. So that's it for constructive waves. Then you have destructive waves. So destructive waves, as you can see here, they have a stronger backwash, right? A stronger backwash in that it erodes or it removes material from the shoreline. So you have a stronger backwash and a weak swash. Then you have a steep profile, meaning because of that plunging breaker going forward, they usually have a steep profile, as opposed to constructive that have a gentle profile. Destructive wave, they have a steep profile, right? They have short wavelengths, so the time that it takes before another wave is formed is very fast, so it's approaching right directly. So if you think of Maracas, those waves are forming very quickly. That is when we characterize it as having a high frequency and they have a short wavelength. Because of that high frequency, they have short wavelengths between them. Then we have 4 main types of wave erosional processes. So for these beautiful coastal features that we have, for example, a bay, right, and headlands, those features are formed through the action of wave by erosion, wave erosional processes. So we have the first one, which is hydraulic action. So what is hydraulic action? As the word suggests, hydraulic has to do with some sort of water. So it is the force of the water that is assumed that this is the cliff face or the headland area and I am the wave approaching, right? It is that impact of the wave against the cliff face or that headland. Remember that cliff is going to be comprised of rocks. Some rocks are porous, so they're going to have cracks or fissures or openings, and as that wave is pounded against that cliff face, it's going to weaken it. It's going to be compressed in these spaces, and it's going to implode. And then you have, of course, it's being eroded, pieces of the rocks broken off. That is what we refer to as hydraulic action. Then you have what we call abrasion or corrosion. And abrasion and corrosion is where you have the wave traveling, but that wave is carrying material with it. So you will see that that wave is taking material and it's being hurled, or it's being thrown against the cliff face and the force of the wave, and that is going to break again pieces of the cliff face or erode it into smaller pieces. Then you have attrition, and attrition is where the rocks itself in the wave, they are colliding with each other, bouncing with each other in that wave. They become more rounded, they become more smooth, and that is the effect of attrition, which is really on the material that is carried. And then you have solution. So some types of rock, like limestone, is very soluble, right? So salt water can dissolve that limestone rock easily, and that process of the seawater dissolving rocks and minerals, we refer to that as solution. So those are the wave erosional processes, and I will stop there for this class. Check me for the next session. Make sure if you like this video, give it a like, a share, and also encourage your friends to follow. Bye.